Our next presentation is from Mr. Paul Vinik. It's about the NCHRP Domestic Scan 1503, Successful Preservation Practice for Steel Bridge Coatings.
Thank you, everybody. Pleasure to be here. I'll try to be fairly quick. We should make up some time. And, this was a collaborative effort by a team. So as an individual trying to represent a team's opinions, sometimes it's a little tricky. So bear with me, and here we go. So first of all, why are coatings important? Probably most of the people in this room have seen these numbers. Total direct cost of corrosion somewhere around $300 billion between 1998 and 2001. Of that figure, $8.3 billion was just for bridges. So my understanding, the Highway Trust Fund is about $30 billion. Some quick math there, you see that the bridges are, almost, what is that, 30% of the whole trust fund. So it's a big deal. And from a cost perspective, it gets very obvious, why we're spending money here. The scope of the domestic scan, what were we tasked to, let me back up just a second. This was a NCHRP scan tour sponsored through TRB. We had Federal Highway participate on the scan tour, and I'll get into that some more, but I wanted to kind of give you the structure of the scan tour, who was behind it, who funded the collaboration, and essentially that was the Academy of Sciences, Federal Highway, and the TRB. So anyway, the scope of the scan. What were we looking at? We were looking at funding levels, evaluation practices, surface preparation, coating decision-making, warranties, coating inspection requirements, inspector qualifications, contractor qualifications, scan team recommendations, and we specifically excluded shop coating. I don't even remember why, but it makes sense to me. Shop coating is, it's the lower fruit is the maintenance painting. At least in Florida, we're getting pretty good service lives out of our shop painting. It's the maintenance painting that this scan tour was focusing on. So the scan tour was myself, Charlie Brown from Greenman-Pederson in the Maryland State Highway Agency, Ray Bottenberg from Oregon, Justin Osell from the Federal Highway Administration, Tom Schwart from Texas DOT, and Mike Todson from Iowa DOT. There were also 12 other states that participated remotely with the scan tour, and they're shown on this slide. So anything green or brown in that slide participated in this scan tour in some way or another. It was impressive to have the number of individuals together specifically talking about coatings and how we were going to improve highway agency coating operations nationally. So the first topic, agency funding levels. All 13 agencies have preventative maintenance programs in place, not a surprise. 6 agencies have dedicated steel bridge preservation programs. The most organized and effective implementers seem to be the ones with the biggest inventory. Yeah, kind of common sense, actually. Maryland has mandated no more repairs to beam ends. And I'm not sure how it's good to mandate it, but did they get there? I don't know. We'll have to ask someone here from Maryland, but that was one of the things that they were trying to accomplish during the scan tour, which was about 2 years ago. Painting. Due to the cost and repairability, paint's considered a bridge element. That's surprising to me. I did not know that prior to the scan tour. In the Federal Highway Bridge Preservation Guide, paint's listed as preventative maintenance action, along with debris cleaning, bridge washing, etc. So what practices were out there for in situ coatings? Well, all state highway agencies performed assessments prior to making any maintenance decisions by following the National Bridge Inventory regulations. It's required every 2 years that the bridges have to be inspected, and a biannual in-service bridge safety inspections, that's done by all states, all of the agencies that participated. How did they select coating candidates? Well, triage using the National Bridge Inventory or element level inspection data. Conduct special coating inspections, and then prioritize which structures were worst and how much money you have. So first of all, the element level inspection data. This was an important nugget, is some of the agencies were very detailed with their inspections. They had element level ratings, across a bridge. Instead of, an area or even, a whole bridge, they were rating individual elements, putting them on the plans, and using those as information to make a maintenance strategy decision. So Oregon, they did the condition of the entire superstructure coating system on an element by element basis. It was impressive. Virginia, the condition of the beam ends and beam end coating systems, just different ways different states approached things. So overcoating, one of the topics we discussed, it was in the previous presentation, but overcoating. The general gist of it was that most of the agencies are moving away from it, that for environmental and safety regulations, cost advantages, the amount of risk, things like that. I remember one of the statements is if you're going to have to do containment, then your cost is going to be almost the same as if you were doing a full removal and replacement anyway. Just things like that. California, Caltrans, they had one thing that was very different than anybody else in the Scantor, and they had their lead-based coatings. They were doing their best to extend the life of their lead-based coatings. They figured it's better to leave it in place and let it work as long as it'll work before removing it. Can't argue the logic. Also, but it was unique. They are also using in-house painting crews to perform overcoatings. And also Caltrans formulates their own paint. Surface preparation. All agencies specified SP10 for total removal and replacement. Across the board, everybody that was participating used SP. It varied for spot and overcoating. All used Guide 6 for containment. No big surprises. This is another nugget that really came out of the Scantor that at least to me appeared to be very beneficial, is Oregon was using ultra-high pressure washing to remove pack rust. They're getting into their bridge bearings and things with ultra-high pressure water to knock out the pack rust and get the salts out of it prior to any other surface preparation. And from the pictures that we saw and the results that we heard about, that was very successful practice. Texas is water blasting before any mechanical surface preparation. And New York's actually using hot pressure washing at 180 degrees Fahrenheit to remove surface contaminants. So how do you do the coating option decision making? What are we going to do? What coating system do we want to apply to this bridge? Well, nationally, the 3-coat zinc-rich primer is the workhorse. That was very evident from the Scantor that that's predominantly what's being used across the country. There was talk about ultra-weatherable coating systems, which your siloxanes, your polyureas, your fluoropolymers, there's several others out there. Anyway, the team was more or less, I guess, frustrated a little bit, is that there seemed to be new technologies out there that had not been well vetted, and we just didn't know whether we could use them or not. They weren't tested, laboratory or field testing, and even though the rumors on the street are that these coatings are very, very good, it's hard to specify one without a good independent lab evaluation. Metallizing, New York and Ohio have been doing metallizing for many years. They seem to be ahead of the rest of the pack. They had good results. They reported good things to the scan team. No rusting, and some of these were not being top coated, you know, just metallizing the steel and not putting a duplex system was not applied. So that's why it says not aesthetic. So warranties. Warranties were another one of those nuggets that came out of this that seems to be a very good contractual mechanism or tool to help ensure quality. I don't know if warranty, Jeff, does warranty fall into QA or QC or both?
Does warranty fall into QA or QC? Well, basically, it's all QA, QC, but the thing is that the warranty is the contractor exhibiting a certain amount of confidence, and is he's buying into it, and therefore hopefully get a better project.
Yeah, the contractor's taking on responsibility, yes. And I was kind of leading you on, but I thought it's both.
It is both.
It's contractor quality control and it's owner quality assurance, both. Here's the states. Maryland's using a 2-year, about 25% of the total project value warranty. Oregon was using a 3-year, 90% of the coating line items warranty. The Golden Gate Bridge Authority had a 5-year warranty, and Ohio had used a 3-year warranty in the past. Now, you know, talking to the scan team, the sweet spot was agreed upon to be about 2 years. And it leverages in-service inspection. It's not so long you forget about the structure, but yet it's quick enough that you can get out there. It is long enough so that you would expect to see premature failures if there was something wrong. You know, 2 years is a long enough period to see premature failures if something was done very wrong. Warranties is it requires the agency to get out there and inspect before the warranty expires. And that was one of the challenges is, you know, which agencies have personnel to go just track warranties. I think Mr. Blanchard said this morning we have 12,000 bridges. So think if you had 12,000 warranties, or you know, even some proportion of them, you're talking about a significant manpower investment. So be it. Maybe that's a good thing. You know, maybe that needs to be done. But so coating inspection requirements, in-house personnel QA inspections, 1 agency. Consultant personnel QA inspections, 5 agencies. Blended were 6 agencies. Minimum consultant certs, all agencies required some level of consultant certifications. NACE CIP or BCI, SSPC, BCI being the 2. And then minimum in-house certification, that just varied by agency. Coating inspection requirements, hold points. You know, that's sometimes, I guess a lot of times overlooked. And one of the things the scan team felt is that hold points should be maximized and utilized, you know, to ensure quality. 100% QA inspection. In other words, you know, don't get out and do your 100% inspection before your contractor demobilizes. You know, once the contractor's demobilized, you think he's coming back out? Not likely. So get your 100% inspection in prior to your contractor demobilizing. Stripe coating, that was another one. Some agencies weren't stripe coating. Some are stripe coating the primer. Some are stripe coating all the coats. But in general, what was came out of this was that the stripe coat needs to be tinted so that you can get a contrast and that inspectors can clearly tell that the stripe coat's been applied. Which coat varied by agency and coating, and you know, the other one was that the scan team didn't really like the wet on wet stripe coating. Felt that was not a good practice. Inspector qualifications. Well, all agencies required training before going out on a bridge project. Primarily on-the-job training and industry-based being NACE or SSPC, and in-house instructor-led training. The contractor qualifications, 9 agencies required QP1 and QP2. 3 agencies required QP3. 1 did not require QP at all. And 1 agency allowed SP7, or QP7, I'm sorry. What else did we see? Well, it came, I believe this came out of Maryland also, but eliminating deck joints. Maybe it was Virginia, somewhere in the mid-Atlantic. Anyway, eliminating deck joints, and that's been in 2 or 3 of these discussions already today. How much I think the fellow from Alabama said it was the bane of all preservation engineers' existence. And so Virginia is right on cue there. Eliminate deck joints wherever you can. One code IOZ system. This system, touted by NASA for years. And, I've seen their test panels and things out. I've been out to the NASA web test site. I've been to their launch pads, and it does very well. Untop coated IOZ certainly outperforms a 3-coat IOZ system. And this is just a picture of some of those panels. Agencies seem to prefer IOZ to OZ, inorganic zinc to organic zinc. And the scan team recommendations. So what were they? Well, agency funding levels. You got to have a dedicated bridge painting fund. That's, if you don't have a dedicated bridge painting fund, you got to get that settled with management. I guess it's fine if you don't have any bridges. Evaluation practices for in situ coatings prior to recoatings. How each person that goes and does an assessment can come back with a different result. So you need to have some consistency. Your inspection needs to be element specific. Surface preparation, use ultra-high pressure washing to remove pack rust. Crevice sealer to inhibit corrosion. And coating option decision making as duplex systems and metallizing, ultra weatherable coatings, and untop coated IOZ those were the 3 top systems deemed by the scan team. Continued use of performance-based contracts, the warranties, specification language. The warranty's no good if you don't define what a failure is. So you've got to specify in your contract, is 1% corrosion enough to void your warranty? Is 1% delamination enough? It's got to be in the contract. Otherwise, your warranty is worthless. Specifications, SP10 for surface cleanliness, paint the beam ends, incorporate hold points, full-time inspection, and stripe coating. Quality control inspection, NACE CIP and BCI. QP1 and QP2 for contractors. Agents, essentially, what to me at least, those come down to training. What we're talking about is, well, are our inspectors trained? Are our contractors trained? Have they passed a certain industrial criteria or industry criteria to show that they're proficient? That's what these qualifications and certifications are about. Agency commitment, that's the bridge, the funding again. Is if you don't have a dedicated bridge maintenance fund or painting fund, then what are you begging for money every time you need to paint a bridge? Tracking coating information. It was amazing to me, and I would throw Florida a little bit under the bus here, is I don't know, many of the agencies aren't tracking the coating systems that they're putting on their bridges very well at all. You go and walk up to a bridge that was painted 10 years ago, no one can tell you what the surface cleanliness that was specified or what the coating system that was put on it. I know they're doing better in the Northeast. I've seen the stencils on the bridges, and however you do it, it's important and a great idea. Joint elimination, we mentioned that. Waste disposal. This was another little nugget that I learned out of the scan team, but the waste disposal, the states felt like, and the agencies felt like it was just better, and many of the states were already doing it. They're disposing of all their waste as hazardous. They're just not messing around with it. They're saying the cost was about the same anyway, and that it reduced risk. So they're just disposing of everything as hazardous waste. And Last slide, well, second to last slide, but this is the web page for the full scan tour, if you're, the report from the scan team, if you're interested. And I thought I'd also plug, this is a costing spreadsheet that Jeff and I put together, and it goes through the different iterations of whether over a 50-year life cycle, if you paint a bridge the first time and then you overcoat and then spot paint, it goes through the different iterations and provides a life cycle cost analysis based on the time value of money and predicting things out based on interest rates, and it incorporates the user costs as well. So it's the cost to the motoring public is included as well. And Jeff, that's not uncommon in the maintenance engineering world, is it not? Do you guys normally include that cost in this kind of?
Which cost is this again?
The user costs.
Yes, we do.
I thought so.
Yes.
So, and that's at your disposal too. Just a quick run out to the TSP2 website. If anybody wants help with that spreadsheet or an explanation, I'll be glad to try. And,
The way that's incorporated, by the way, and it's not always done on maintenance painting projects, but it's done through A+B bidding, where you try to basically incentivize the contract. That's what Brian Blanchard was talking about earlier, that if they can basically beat a schedule, he can get a bonus. And that's what contractors respond to money, as the contractor that presented earlier stated. So that's how you incentivize contractors to get done early, pay them some additional bonus money.
yeah, and in this spreadsheet is, if you spot paint the bridge, if you do a removal and replacement, it helps you calculate the costs and then compare the costs of the different options.
And the other aspect is liquidated damages. If they run over, you have to hold them accountable for that. Latent defects. Don't go. Latent defects. Basically, that's, I think it was 820 days, if I recall correctly. And that basically, since in Florida. And so what happens is that we have a 2-year inspection cycle, even for when we go to 4-year inspection cycles for a bridge. So we're always going to be inside that latent defects period. And I know that basically you have to have performance measures in order to really measure this. But this is the opportunity to really measure a paint system, even if you don't have warranties. And I really believe in warranties. I'd like to use that more. Did we actually have criteria for which we could judge how well a paint system is going within 2 years that we could hold a contractor accountable to in our spec? We did, right?
In Florida, we had a bridge structure with a 10-year warranty. And we had a percent corrosion defined, I'm going to throw out some numbers. I don't know that they're absolutely. ASTM D610. And then delamination was defined as anything you could remove with a dull putty knife. Long story short, the bridge structure started corroding after about 2 years, and we invoked the warranty and had the contractor come out and fix it.
But mostly it's judged by color retention and
Color
gloss.
retention, gloss retention.
Right. So we have the ability in Florida to do that. I don't think we're really taking advantage of it, as Paul pointed out, the way we should. And I know there's at least a couple folks in Florida DOT that are here. We should be doing that. But I'm curious, how many other states out there have a latent warranty period? Does anybody, aside from Florida? Show of hands. Virginia? Anybody else? Some state back there? So this is something that if you can actually work into your contracting program, you can actually hold them accountable a little bit towards your coding system. And that's something that I think we need to take more advantage of in Florida. And now that I've been spurred to life, I'll be pushing that one.
No, what I was going to point out is you're going to do a bridge inspection every 2 years anyway. So if you line up your warranty with the bridge inspection, maybe it's not extra manpower or extra work. If you get the two things concurrent.
Yes, 720 days versus 820 days. You can basically call the contractor back in. They're under current. They basically have to go out there and make good on it. Either that, or you can work out something where you take a reduction in payment and force them to pay back, whatever.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.